Hello students, welcome back. This is Shivaleela from Upper Public School. So you may wonder by seeing this all, isn't it? What are you seeing here? See here, this is the new chapter, fifth chapter we are going to deal in this new way. So what we are going to do here, you can see, right? Yes. See, let us start our next chapter here, geometry. One of the part. Even in the fourth chapter also we have done in the same way. Here also something, a slight changes we have done. Okay. Now let us go to the fifth chapter, that is understanding elementary shapes. First of all, shapes. What is shape? Shapes are nothing but the starting step for geometry, isn't it? Yes. So come on, let's start to study in detail in this chapter. Okay. So first, let us go to the concept map of this chapter. What is the meaning of concept map? Concept map is nothing but what and all we are going to learn in this particular chapter. Okay. In this particular chapter, which and all concepts we are going to study. Come on, let us see. Basic geometrical ideas have been studied in fourth chapter, and we are going to study about shapes now. So in this chapter, what and all concepts we are going to study. Come on, let us start. First, in shapes, we are going to deal with the revolution first. After revolution, angles, then polygons, then triangles, afterwards quadrilateral, lastly 3D shapes. Okay, so now let us go in detail with all these concepts. Okay, shall we? Come on. First, revolution. Okay, so what is meant by revolution? Revolution is nothing but moving an object in a circular motion. You have heard this word in not geometry, geography. Earth revolves around the sun and the moon revolves around the earth. But earth rotates its own axis. Then what is the difference between rotating and revolving? Rotating is nothing but rotating on its own axis. If I turn a full round here, that will be rotation. If I start to move from here and if I cover a circular motion here, that is revolution. Okay. So where we'll see this revolution in our day-to-day life? Everywhere. See, if you can watch your clock, wall clock, or watch. Now watches are digital, right? So leave it. Let us see the wall clock. There we will observe this revolution. Hands of a clock will move in a circular motion, isn't it? Here we will and in direction also, isn't it? Yes. And here, one complete revolution shows you one complete turn shows you one revolution. Then half, obviously half of a revolution. Then one circle can be divided into 4 equal parts, isn't it? So, half of revolution, a straight angle gives you half revolution. Then one right angle shows you 1/4 of a revolution, because one circle will be divided into 4 right angles. Then one right angle shows you fraction. 1 out of 4, 1/4 of a revolution. Understood? And one straight angle shows you half revolution, because one straight angle is nothing but 2 right angles. That's it. Got it? Now let us see some example. See, if a hand of a clock starts to move, see here, if a hand of a clock starts to move from 10 to 7, it shows 3/4 of a revolution. I give the answer here itself. How? That's a question mark. So see here, directly if the hand of a clock moves from 12 to 3, it shows 1 right angle. That means 3 hours gives you 1 right angle. Then 10 to 7, how many hours? 10 to 11, 1 hour, 12, 1, 2, 3, 4, 5, 6, 7, total 9 hours, right? So 9 hours gives you 3 right angles. 3 hours, 1 right angle. Then 9 hours gives you 3 right angles. Out of 4 right angles, 3 right angle it covers, right? That's why it shows 3/4 of a revolution. Got it? The same concept will apply for direction also. Come on, let us see that too. See here, you can see here, if the hand of if a person or if we starts to move from north to east in a clockwise, what is meant by clockwise first of all? Clockwise is nothing but how the hands of a clock moves. From 12, it starts to move towards 1, 2, means like this, right? Towards left side, right side. If it starts to move in reverse, anti-clockwise, okay, so not from north to east, if it starts to move, it gives you only one right angle, clockwise. If the same north to east, anti-clockwise, it gives you 3/4 of a revolution. Understood? I hope you got that concept. What is meant by revolution? Revolution is nothing but moving an object in a circular motion. Okay, only these concepts why I'm explaining, because this is in your portion now. You should get to know that. That's it. Okay. Now the next topic, that is very, very important. Okay, this is useful for your higher studies also. That is nothing but angles. See, even here also for angle also we have a like concept map. Along with that concept map only, let me explain. See here, angles. Angle, almost you know how to use angle. How to measure angle. What is the instrument to use? Measure angle. The instrument is nothing but a protractor. We'll use protractor to measure the angle. And if the initial ray and final ray doesn't start to move, then there will be no angle only, isn't it? There will be no angle formed. That's why it measures 0 degree. Therefore, it is nothing but 0 angle. There are 4 standard angles. Those measurements will not change. They are nothing but 0 angle, its measurement is 0 degree. Right angle, its measurement is 90 degree. Straight angle, its measurement is 180 degree. Complete angle, its measurement is 360 degree. Now, see, if the angle lies between 0 and right angle, then it is known as acute angle. That means acute angle measurement will be greater than 0 degree, less than 90 degree. Therefore, it is nothing but acute angle. Then, if it reaches 90 degree, final ray, if it reaches 90 degree, then it is right angle, right? Then, again, if it starts to move, then more than 90 degree, less than a straight angle, you can observe here, less than a straight angle, more than 90 degree, it is nothing but obtuse angle. It lies between right angle and straight angle. Okay, it is nothing but obtuse angle. Then straight angle is nothing but a straight line. Initial ray and final ray, both forms a straight angle. Straight line. It is nothing but straight angle, right? Then again, if the final ray starts to move more than 180 degree, less than 360 degree, then it is known as a reflex angle. 360 degree complete angle, its measurement will not change. Then see, you can observe here on this slide here. See, complete angle and 0 angle looks alike, no changes only. Then how will you get to know that is 0 degree and this is complete angle? How? See here, in 0 angle, initial ray and final ray, they are on the same place. They did not even start to move. But in complete angle, it started to move and completed one complete revolution only. That's why it is complete angle. Got it? So these are all about angles. And you should know also, okay, in your higher classes, it is just your mind work. You should know all these types of angles. There are total 7 types of angles, and the 0 angle we won't use anywhere. Just you should know that for that purpose we have explained. Okay, it should. It's not compulsory. We are not using 0 angle from onwards. Okay, but you should know 0 angle is also a type of angle. Okay, next is nothing but, see, while explaining in basic geometrical ideas, lines, intersecting lines, while explaining the lines, intersecting lines have been explained, isn't it? What is meant by intersecting lines? When 2 lines intersect each other, it is known as intersecting lines, isn't it? Here, if those intersecting lines, see here, you can see here, if those intersecting lines, okay, intersects with 90 degree angle measurement, then they are known as perpendicular lines. Okay, the same intersecting lines only will be known as perpendicular line when the angle measurement is 90 degree. Okay, so if then what is meant by perpendicular bisector? Here on this slide, it is given perpendicular bisector. What is meant by that? Bi means two, sector means part. If we divide a given line segment, into two equal parts with 90-degree angle measurement, then this vertical line will be known as perpendicular bisector, because this vertical line is dividing the horizontal line into two equal parts with angle measurement 90 degree. If horizontal line is dividing vertical line, then horizontal line will be the perpendicular bisector. That means the perpendicular line which bisects means dividing into two equal parts. Got it? Yes. Now, come on, let us go to the next part, that is polygons. See, already you have studied in 4th chapter, polygons. Then what is the new thing to learn here? See here, polygon, as you know, it is a closed figure, right? Made up of sides, right? Then what is the new thing here? Here, same polygons you are going to study, but you are going to study triangles and quadrilaterals in detail. Before that, let us know the polygons once again. Okay, the name of the polygon is nothing but a closed figure made up of sides, means line segments. Then the name of a polygon depends on the number of sides. If there are 3 sides, see, with the 2 sides, it is impossible to draw polygon, isn't it? So therefore, then the basic polygon starts from 3 sides. 3-sided polygon is nothing but a triangle. Then a 4-sided polygon, quadrilateral, right? 5-sided polygon, 6-sided polygon, 7-sided polygon, 8-sided polygon, 9-sided polygon, and 10-sided polygon. They are named as triangle, quadrilateral, pentagon, hexagon, heptagon, and octagon. Then nanogon and decagon. Okay, nanogon and decagon. 9 sides are 10 sides. Did you get it? Then if there are n number of sides, it is known as n-gon. Sides we can't write. There is n number. It might be any. Right? Now, here why we are studying it once again? We are going to study triangles and quadrilaterals in detail. Okay, first we'll go to triangles. Okay, triangles. How we are going to, classify the triangles. See, there are total 6 types of triangles. We can classify the triangles in 6 types. 3 based on sides and 3 based on angles. Okay, so then first let us study about based on sides. If the triangle has all 3 sides equal, you can see here. See, if all these 3 sides are equal, then it is known as equilateral triangle. Not only sides, along with that, in equilateral triangle, angles also will be equal, all 3 angles. Okay, this is a special property. In equilateral triangle, not only 3 sides, even angles also will be equal. See, equal, lateral sides. Or if all 3 sides are equal, then it is known as equilateral triangle. See, if in case only 2 sides are equal, what to do? Here, see here, it's already there, right? Yes. If 2 sides are equal, then it is known as isosceles triangle. Again, iso is nothing but 2 only. Okay, so 2 sides will be equal. Then that type of triangle is known as isosceles triangle. In equilateral triangle, all 3 angles were equal. Then what about in isosceles triangle? Here, which 2 sides will be equal? Their opposite angles will be equal. Okay, understood? Now, see, 3 sides equal, equilateral, 2 sides equal, isosceles. Then what about the 3 of unequal sides? That is nothing but scalene triangle. Okay, you can see here all the 3 sides are of unequal measurement. Okay, all the 3 sides are of different measurement, and along with the angles also. All the 3 angles are of different measures. Okay, next, these are the 3 types based on sides. Then based on angles. See, we can't draw a triangle with 2 right angles or 2 obtuse angles. It is highly impossible. So therefore, 2 angles will be acute only. A triangle will be having 3 angles. Among these three, two will be acute only. The remaining one, if that is also acute, then the triangle is known as acute angled triangle. Okay. Then, if that one is right angle, that is known as right angled triangle. If that third one is obtuse, that is known as obtuse angled triangle. You should know all these types of triangle because it's very important to study. Still, you have to learn the properties on this triangle in your higher classes. Okay, not only this much. There's a triangles and quadrilaterals you are going to deal in detail even in your higher classes also. But to get to know all those concepts, these are very important. Now let us move to quadrilaterals. Triangles over. Let us move to quadrilaterals. Then quadrilaterals. How we are classifying the quadrilaterals? First, let me give the names only. Okay, what and all quadrilaterals you are going to learn here. Okay, because see, you already got to know that a quadrilateral is nothing but four-sided polygon. Then you may get confused that already in your lower classes you have studied the shapes rectangle, square. Only these two shapes you have studied, and these two shapes were also four-sided polygon only. But why why it is not mentioned as quadrilateral? Then what is the relation between this quadrilateral and square and rectangle? All these let us learn here. First, let us see what are the classification of quadrilaterals. Then let us go to in detail. Okay, let us go in detail with all these shapes. Okay, come on, let us. Quadrilateral. Here first we are going to deal with the trapezium, then parallelogram, then rhombus, yes, rectangle, rhombus, and then square, lastly kite. Now let us know what is trapezium. Okay, trapezium is nothing but, see, quadrilateral, as I said, four-sided polygon. If it is drawn randomly, if there is no any special thing to observe, then it is quadrilateral. Four sides are there, it is closed, then it is quadrilateral. If among those four sides, if any two sides are parallel, either horizontal sides or vertical sides or diagonal sides, any two sides, if two sides are parallel, that means if a quadrilateral with one pair of parallel lines is known as trapezium. Okay, trapezium, see, you can observe here in this shape. See, in the first shape, two sides, horizontal two sides are parallel. In the next shape, those other two sides are parallel. Okay, remaining two, we are not bothering. If only one pair of parallel line is there, it is known as trapezium. Then, what about a two pair of parallel line? That is nothing but parallelogram. Okay, in the parallelogram, both the sides will be parallel. That means measure of both opposite sides will be equal. You may get confused. The same thing have been studied in rectangle. Opposite sides are equal. Then what is the relation between parallelogram and rectangle? See here, you can observe here very clearly. Angles are different. In a parallelogram, obtuse and acute will be there. Okay, so lines are parallel. That means both the pair of lines are parallel, means measure of those lines will be equal. Why? This is a question mark. No? Why is it necessary? Yes, because parallel lines are nothing but the two lines or the lines which moves with equidistance. Then if these two lines and the other two lines are also parallel, then they have same distance between them, isn't it? Therefore, the measure also will be equal. If this parallelogram with different measurement, if it turns to give you right angle, you will get rectangle. Okay, so rectangle is nothing but the same parallelogram with right angle. Okay, then see, as I said, opposite sides are equal in parallelogram. Same thing in rectangle also. If the parallelogram, opposite sides are equal, what if all four sides are equal? If all four sides are equal, then it is nothing but rhombus. Here in rhombus, all four sides will be equal. See, you can see here, all four sides are equal. Okay, all four sides are equal. The same concept you have studied in square also. There also four sides were equal. Then what is the relation between rhombus and square? The same rhombus, here also, angle. You can observe the angle. Obtuse and acute angles are there, right? Obtuse angle and acute angles are there. If those angles are changed to right angle, the same rhombus change its shape to right angle, then it is known as square. Okay, the same rhombus with 4 right angle is nothing but square. Okay, then lastly we have kite shape. Till now we studied about parallel lines. Parallel lines were equal. We had one pair of parallel lines for trapezium, 2 pair of parallel lines for parallelogram, the same parallelogram with right angle, rectangle, the same parallelogram with equal sides, rhombus, the same rhombus with right angle, square. Then in kite, we are not going to deal with parallel lines. Here we are going to deal with adjacent sides. You can observe here in the shape. See, adjacent sides, if 2 adjacent sides are equal, then in kite shape, 2 adjacent sides will be equal. Along with that, their sides and angles also. Which 2 adjacent sides will be equal? No, their angles, corresponding angles also will be equal. Okay, this is all about quadrilaterals. See, we have studied 6 types of quadrilaterals, isn't it? Yes. Now, lastly, let us go to the 3-dimensional shapes. 3-dimensional shapes is nothing but a 3D shapes. What is 3-dimensional? Then what? Till now we studied shape only, triangles. 6 types of triangles and 6 types of quadrilaterals. Then are they not the 3-dimensional shapes? No, they are 2-dimensional shapes because they have length and breadth only, right? Till now they had a length and breadth. Then what about this 3D shape? Here 3 dimensions will be there. Okay, 3D shapes, 3-dimensional shapes can be defined as they have a 3D shape will be having 3 dimensions, that is nothing but length, breadth and height, right? So these 3 dimensions will be having in that shape, that is known as 3-dimensional shape. So which and all 3-dimensional shapes we are going to study here? See, almost all shapes what you have are 3 dimensions only. We can give a plenty of examples for that. First, let me give the examples along with the shapes. First, we'll go to cube. See, this is a cube. This will be having 6 square faces, right? 6 square faces, 12 vertices, 8 edges, isn't it? So this is the points to say on cubes, because you have already studied this cube and cuboid in your lower classes. Then what is the example for this cube? See, regularly you might have seen in class chalk box that will be in cube shape, and you will be playing Rubik cubes, isn't it? Rubik cube, that is also perfect square shape, and dice, Ludo dice, that also in cube shape only. Next we'll go to cuboid. Our matchbox, geometry box, and our table, what we have, our board, almost everything is in rectangular shape only. If we have the 3 dimensions for that, then it is nothing but cuboid. In a cuboid, you will be having either 6 rectangular faces only, or else 4 rectangular faces and 2 square faces. Okay, so this 2D representation will be having 4 rectangular faces and 2 square faces, or all 6 rectangular faces only. Okay, then we'll go to the next shape, that is cylinder. You can see here cylinder how it's dancing, isn't it? Yes. See here in cylinder, you see cylindrical shape. See, we have chalk, pen, chalk piece. All these are in cylindrical shape only. Okay, this is cylindrical shape. See what what is the 2D representation of this cylindrical shape? See, already you have seen here in this video, right? So if we open that, we'll get a rectangular face and 2 circular faces. Those 2 circular faces will be covered up and down. Okay, So that is cylinder. That's all about cylinder. Then sphere, ball, spherical shape. Everyone know that. Our earth is in spherical shape only. And ball, there's laddus. Yes, very sweet. That is also in spherical shape only, isn't it? Yes. Then we'll go to cone. Then don't get confused what is cone. See, all of you are very familiar with birthday cat, ice cream cone. That is nothing but a cone shape. Okay, you will get this cone shape with the cylindrical shape only, from cylinder only. If you cut that cylinder, I mean with the right angle, I mean from center only, if you cut it in the right angle triangular form, you will get a cone shape only. Okay, then next we'll go to prism and pyramid. Here, these two I'll say together at a time. Prism and pyramid, these two names might be new for you, but don't worry. These are also 3D shapes only. Here, where we'll use a pyramid. Here in pyramid, we'll be having rectangular faces and triangular faces. Okay. So here, where this prism will be used. See, prism will be used to refract a white light to get Vibgoya, 7 color, rainbow colors. You'll be having rainbow colors, Vibgoya, right? To get that light, we have to pass white light through this prism. Okay, if we pass, we will get that colors. There we will use prism, and that you will get to know in your higher classes. Okay, don't worry, you will get to know in your higher classes. Now you just be familiar with the shape, I mean with the name, not prism. Then pyramid, you know, Egypt. Pyramid means Egypt only. Everyone will get that only, right? Here a pyramid is a triangular pyramid, rectangular pyramid will be there. What is this triangular pyramid, rectangular pyramid and all? Triangular pyramid means base will be triangle. Remaining, see, upper faces will be triangles only. But if base is also triangle, then triangular pyramid. If base is rectangle, rectangular pyramid. Okay, this is all about the 3D shapes. I hope all of you have enjoyed this class, isn't it? How was the class? So now let us recapitulate all what we have studied in this class. Yes. What and all we have studied? We have studied a revolution. We have studied a detailed types of angles. We have studied a number of polygons, 10 number of polygons. Am I right? No, only 7 we have learned, no? Or 8? Yes, 8. From triangle till decagon we have learned. And triangle in detail, the classification of triangles based on sides and based on angles we have, isn't it? And the quadrilaterals. Quadrilaterals also same way. In detail, 6 types of quadrilaterals we have learned, and dancing 3D shapes we have studied, isn't it? Yes. Hope all of you have enjoyed this class. Keep enjoying like this only. We'll meet in the next class with exercise part of the start. Until then, keep smiling, stay at home, stay safe. Bye-bye.